I'm going to do an unprepared presentation on Nixos. So this is basically the project. It was started quite long ago, I think in 2004, something like that. And it consists of Nix packages. It's a little bit too loud, eh? It's okay? Okay. Yeah, I'm behind here, so that's why it's that loud. So basically, Nix is a very limited functional language designed only to be the tool set for packaging. And the goal is, so first the problem we're trying to solve. Nowadays, how we package software is...
Sorry, can you increase the font size of the page?
Something like this?
Maybe a bit more. Okay, I think it's okay.
Okay?
Thank you.
Great. So, currently the distributions pack software by giving the whole file system as an input. So, the make scripts, the make file would go search, user include, user local include, and so on, and so on. And that breaks in a lot of possible ways because there can be different versions of software installed on different parts of the file system. So what Nix does is it tries to isolate everything when building a package, and it does that by removing the whole file system that's currently installed, and the whole environment is clean, and provides only a very limited set of tools that are used: sed, make, and GCC, and a few others. So then you actually, when you have that isolated, you actually specify which are the dependencies of a package, and so on. To go further than that, all the input that is provided for the package to build is hashed. So you get a hash, and that hash changes every time you basically change the instructions for the package to build. And in that hash are also the hashes of dependencies. So if you change one package, all the stuff that depends on this package, their hashes will also change. So what you need is that when you change the way that the package builds, you know how that propagates to all the other packages, and you can rebuild those packages. Let's take quickly a look. So this is Nix store, and here are all the stuff I have currently installed. So you can see like the hashes in the beginning, and then the name of the package version and the derivation. So all the packages are isolated, and then if I go for example, let's do it like this. So then all the binaries that are in the bin are basically symlinked into those packages. So it's completely isolated, and then the whole system basically symlinks to these packages for whatever it needs. And this provides a very, very interesting things, like people, like users, root users, and so on, can install packages, and there is a global like repository of stuff, of packages. So if I install as a user a package and it's already installed on the system, it will not duplicate, and so on. It will just symlink into my user account. So if I go to like my user shell and I say Nix and install, I don't know, Tmax, yeah, it's gonna just symlink because it's already installed on my system. So this is Nix, and now I'm gonna show you Nixos. Let me just find my. I have too much things open. Here. Oh, watch out. And now the Nixos. So Nixos uses the Nix package manager and provides the declarative configuration of the system. So what we see here is, for example, I say networking hostname is Boronichke. So that's how I set my hostname, and then I say networking firewall enable is true, and allow TCP ports. And I don't know, time zone is Europe, Ljubljana, and there's a tons of stuff. So for example, here I say enable X server and I configure synaptics and the desk. Well, let me do it like this. So here I say the window manager is i3, desktop manager is Xface, display manager is Slim, default login is my name, and so on and so on. So basically, that's how you describe the whole system. And then when you want to like upgrade and use that config file, you say Nixos rebuild switch, and that will what that will do is figure out the changes and upgrade the system. There are also commands like dry run, so you will actually see which packages will be downloaded and so on. There's also build VM, so basically it will take all this configuration, build a virtual machine, so you can test all the configuration, and then when you're okay, you can deploy to your system. So that's kind of the point. So if I say switch now, it will basically look for changes, and I think I upgraded before, so it's not gonna do anything new. Yeah, basically just reconfigure some stuff again, and that's about it. So so that's Nixos part. And then we have Hydra. This is where the fun begins. Basically, if I go to Nixos, so this is basically a build system for all the packages. If I commit a change to a package, how it's built, Hydra will pull from Git. It will know which packages changed. It will build those packages and provide a binary form of those packages. And what Nixos will do when you say Nixos rebuild switch, it will ask Hydra for that hash. And if Hydra has a binary package with that hash, it will download it and just unpack. And if not, it will compile it on your system. So it's a mix of a source distribution and a binary distribution, which is, as far as I know, a really unique thing. And so by the ways of having this configuration state for whole system, you basically can do this in a very repeatable way. So Nixos is built on, I think, 4 PhD theses, and there is now 2 new one. I'm not sure about the numbers, but now they're doing a Nixops, which is basically mass cloud deployment tool. So you can have like these configurations for different machines, and then you say this is the global configuration, and these are the little bits that are different for each machine, and then you just push that to I don't 20 machines in the Amazon network, for example. So I don't know if there's any examples here. There should be a manual somewhere. I'm not sure. There was?
There was examples.
Okay. Well, let's. Yeah, so there is one section that you define like how to deploy to the EC2. Yeah.
Thank you.
Something like this. So basically, this is the Nix language, the functional language, and here you define like the EC2 parameters, and then you define machines, and it will build all the packages locally, and then push just the binary diffs to the machines. So if there is only one package missing on one machine, it will just upload that, not reconfigure the whole system and inspect and so on. Because what you build on your local machine and remote, it should be the same. So only the binary difference is the stuff that should be uploaded. So yeah, that's that. Maybe we should take a look at how the source, so we will not be scared about how you specify a package, for example. Nix packages. And Nix packages is basically now a collection of packages packaged with a Nix manager. So if you go to packages, for example, we will take a look at Python. So we actually do something related to Python. Level. There is Python packages. So if we go well, to some similar example. Where's something? So arc parse. So basically there is a function that we built called build Python package, and then you say the name and you say the source, fetch it from this URL, and then you verify the diggest, and then you say build inputs. These are the dependencies to build the package, which is unzip because and then there's do check, which will run the tests. So this package doesn't have tests apparently, and then just the metadata. And what it does is when you set meta.platform, which is not set here, Hydro will know for which platforms to build this package. And the Nix package also builds for FreeBSD and for OS 6 and for Windows. And the Nix OS is built only on Linux kernel. So you can use the Nix package manager on any existing Linux distribution and so on, just to have a repository of packages that you can install. For example, I don't know if I'm a scientist and use matplotlib and so on, it's hard to build those packages. Yes, question?
Can I ask what architecture does it support? Can I run it on my laptop?
Yeah, so what?
Could you repeat the question?
Oh, so he asked what architectures does it support. So Nix currently builds for well, the standard ones, the 32 bits and 64 bit, the Darwin, it's online? Where? In the Nix packages, yeah, you're right. Okay, so let's open that.
I mean, Hydro is only building for E686 and
Yeah, so this. So this is what it's building now. So ARM is not supported because it's hard to build ARM. We have spent some time on making cross compiling for ARM. I'm trying to push that, but you know it's a fun project, so it's advancing slowly. But we have one crazy guy who already runs Nixos on Raspberry Pi, but it's not sufficiently supported, so Hydra does not build. You have to cross-compile it your own on your system and then use those packages. Basically just copy them to the Nix store and that's it. It's not really convenient at the moment to do that, but yeah. So this is basically like a really quick ad hoc introduction to Nix. If I were more prepared, I could show you Nix ops. You can say like you define like two machines and then say deploy, and it will fire up to virtual boxes and like install all the stuff, and you have that ready. And then you say like services.ssh enable and say deploy, and it will figure out download SSH and run it with some parameters on both machines, for example, and so on. So maybe I can show that on my machine just quickly. There was one question. Yeah.
I have two questions. We asked the binary packages, are they relocatable?
Are the binary questions what?
Binary packages.
Packages, yeah.
Are they relocatable? Because you know when you do make install,
Yeah.
you have absolute path somehow more or less.
LDD
And can I relocate it to different directory, the binary package, with dependencies?
Yeah. So the question is if you can relocate the binary packages. They link to the Nix store. So
Yeah, but so is the Nix store the local relocatable? Is the idea?
maybe you can answer.
maybe show just LDD on the ls command, for example.
LDD is.
LDD, which ls?
Like this.
So,
Okay, so it's absolute path.
yes.
So it's always no relay. Okay, only one question is Nix, the package manager. Can I use it without root?
With what?
Without root.
Yeah, you can use it without root.
Everything. I can bootstrap without root and play.
Yeah, so to repeat the question, can you use Nix without root? Yes, you can install it on your user account and then install packages as a user. Although that's there is some extra setup than normally, but you can do.
I already tried and I failed.
Okay.
Maybe you just don't support it and it's the answer for me.
No, if you want binary support, you will need the /nix directory.
Yeah. But
So
I can build myself a Nix storage.
you could take your home directory, create a Nix directory there, but you will not be able to use any binaries because they're obviously hard-coded where they find the libraries. So you will not have support from GitHub. You will need to compile everything yourself.
Okay.
But this work, like if you currently do configure make install in your home directory, you can use Nix to do that for you.
So one side effect is also that all this stuff is read-only, so you cannot like create package, like you cannot modify the packages once they are installed. This is because Nix has this idea called impurities, which means if you build with the same parameters on the same system on two different laptops, the result should be the same, and well, that's why the hashes, and that's why you should not modify the whole package. Otherwise, you break the Nix. So yeah.
What you said before that Nix will figure out the changes. For me, that sounds like it looks at the config and it looks what changed the last time. I think a better explanation is to say it will realize the system configuration, and whatever it needs for that, it checks whether it cached it in the store. As a side effect, the packages are getting built. And if you see it as a functional language, you call the function, and as a side effect, you get the package being installed in the store. And if it's not there already, then it will be built. And if you change something in your system, it will just realize the whole system. It will figure, I have all that already, and only create things it's missing, and then in the end link it together. So it doesn't know a concept of this changed compared to before. It just knows how to do this and how to reuse things that exist already.
So with this, I can treat Nix to reuse some system packages.
Sure.
Yeah.
No,
so because I
yeah.
really want to use Nix, but
It's like an additional packages. So you can, yeah.
I have no root and I need to compile a lot, and I don't know how to do that.
Yeah.
Especially on Darwin, it's called a standard environment, which is on Darwin faking certain things, like not to build them, but just use the linker from OS6 and so on. And you can define it yourself, other standard environments.
So one of the results of this system is because everything is like, it keeps a history of your upgrades. You can roll back, so you can upgrade the binary packages and do some stuff, and then say roll back, and it will go to the previous state, which sounds really magic, but it actually works.
It's an excellent idea.
Show the Nix profiles, something like that.
Yeah.
Yeah.
So this is basically like a history of everything. And how that works is when you boot your system in grub, you will get like a history of snapshots, and you can select in grub which one to boot. And by default, it boots the latest one, of course. So maybe just so one of the cool thing is you can say like how many packages you can download in parallel, and because there is no like extra configuration, it just needs to download and extract it. So it's really fast when you're like adding new stuff. So any more questions? Yeah.
Can we combine different configuration files?
So the question is, can we combine different configuration files? So you mean like you can split them in two and so on? Yeah, Nix has this require function, or that will import like a config file inside. So
There is a server of configuration files that are known to work that we can reuse and just
so
define the work.
so maybe I will try to show. I don't know if this is gonna work. Okay, it kind of worked. So basically on the terminal F8 you have all the things you can define in Nixos. So if I go, for example, SSHD, come on, something more simpler. So here, for example, is like the networking stuff, like extra hosts, enable VLAN, allow ping, allow TCP ports, UDP ports, and blah, blah, blah. So you have all options that you can define for Nixos. And this is like automatically generated when you add new features to Nixos. So you have basically documentation on your terminal. And there's a lot of stuff I can configure. Nice. So any more questions? I hope this will, okay, kind of works. Yeah.
Maybe you already mentioned that can we compile also the compiler and the kernel?
Again, can we compile?
Yeah, compiler, GCC or the kernel also?
You mean if you can compile GCC with?
Yeah.
Yeah, you need to compile GCC in order to compile all other packages. So, and maybe I can show what happens if you add stuff. So for example, here I have like extra users electric, and I say name is electric, create home is true, extra groups is like wheel, and so on. And this will also create the user. And here like Chromium, I have disabled Java explicitly just in case they enable it globally. And Adobe Flash I have enabled, and so on. But if we go up, I'll have to change my passwords later.
So you store passwords in clear text.
Yeah, well, that's one of the things that we have a debate how to treat the passwords, and it's a hard problem with the current system, but we're working on it.
No, it's doing it together.
So, for example, something that I don't have installed. Java. No, some service. Well, yeah, we can add that to the packages.
MPD.
So like, Emacs. I almost don't see anything, so I hope I typed it correctly. But no, what should happen is it will download all the dependencies for Emacs, and yeah, so it's just the Emacs package. Yeah, it's 35% and so on. So you can ask questions in the meantime.
Yeah. What is happening beneath it? Like there is an expression for how to compile Emacs. It was now consulting Hydra, whether you see there cache Nixos org. It was consulting Hydra. Do you have a replacement or substitution for this hash? And Hydra told, yeah, we have one, so it's downloading that. And if you would change something in that set of instructions to compile Emacs, then you would get a different hash, and Hydra doesn't have a binary for you, so you compile from scratch.
So yeah.
But you always get it's a transparent binary support. It's not like you need binary support. So if it's there, you will get it, or you can set up your own binary caches to have your own configs and stuff.
I wasn't in the beginning of the talk. You might have answered this, but the question is, how about the conflicting binaries? Like one application requires binary libraries. Sorry, conflicting libraries. Library older and the other newer.
Yeah, so that's basically what Nix solves. So you can have, multiple versions of the same library installed, and then you symlink to the, to one package and to the other and to the third. And for example, when we have like a Postgres service, you define which Postgres version you use, and you can have multiple of those, and so on and so on. So that's also one of the things we're trying to solve. So we're out of time?
Yeah.
Okay.
Sorry.
Well,
Thank you. Thank you.
There are some cards. I'm really interested in this stuff, but I couldn't come earlier, so I